Hello everyone, welcome to another class from Spring AI. So in today's class we will talk about filter expressions in vector store similarity research. So in our previous class we looked into a vector search in our PGVector store. We used a example of a movie, so where we embedded our movie different movies into our PGVector store, and then we gave a query of a plot, like a brief plot of something or a genre, and it could give me, based on the semantics similarity, it will give me a list of movies right out of this. So we were searching on the vector embeddings that we stored in our piece vector store. So in today's class, what we will look into is filtered expression, how to use filtered expression, right? So for that, first let's understand what are filter expression. So I think yeah. So filter expressions are metadata-based constraints applied during vector similarity searches to combine semantic matching with structured data filtering. So here what it is trying to say. Like when we are storing data, right? Like in this case, like movie data. So we were storing the metadata information and also the plot of it, right? So we were storing all this information. And the embeddings was on the plot, right? So when we are searching it, right? So we were searching, if I'm giving some basic query, it will do a embedding search on the similarity search on that embeddings, and then it will give us a result, right? So based on the like most similar ones. So here you can understand, right? So since we have the information, the attributes of the movie, like the genre, the title, the release dates, and all those information. So when we are making a search, we can actually, what we can do is we can segregate it, right? We can if we have these fixed attributes. So if I give if I want to know what are the similar movies, so I can pre-filter them using like something, I want only movies from this release date to that release date, right? Or I want only movie which are of English movies or Hindi movies or any other like attributes which are fixed in nature. So this, like to filter that out, this is where we can use filter expressions in vectors, right? So this is kind of what we are seeing here. It's a hybrid search. So where we are doing a combine with vector similarity with exact attribute matching, right? So these are saying a SQL like syntax we will look into in our code. And this is basically what we are calling as metadata. So we are some filters are there. We are using some attributes are there. We are using filters of attributes. So why we need filter expression? We already talked about it, right? Some we might have business criteria on specific metadata information, right? So based on this, we can filter out beforehand, right? So we don't need to, which will give us a better result actually. And also it will reduce our unnecessary vector computations, right? Otherwise we were also computing those information based on the plot, which one right belongs to, and all those information we had to compute it, right? So this we don't need, right? Because we already know from the metadata information. So the different operators that are there are, so you can see here, it's very intuitive to understand. Equals to is cube, any, gt, greater than gt is greater than equals to, and so on. The logical operators being and or not. Set operations like we use in our MySQL, so if and nim, right? And group operations is group. So we'll go into this in our code. So if I go to the code, so here if you can see here, so let's say, so I'm just taking a example, right? So here initially, so let's get a quick view of it. So we are storing it in our in-memory vector store. So we inserted few movie documents. Here if you can see, text is this. We are inserting the metadata, title, year of release, and what is the genre, right? So these are few information that we were storing. Here, as you can see here, we are using the in-memory Olama embeddings, right? So once we are indexing it, now if I see here, so I'm just taking one simple example where from the request, I'm just taking the genre. And here I'm just, for now, I'm hard coding the expression so that we can see into what are the different expressions I'll play around with this, right? So here, if you see, so there, to give you a quick, first of all, let's go to the similarity search function. So here, if you see the similarity search function, so what it takes is, these are same as the previous class that we talked about. The extra thing that we are doing here, it is the filter expression, right? And we are passing on an expression here. So this is the only key difference that we are using here. So this filter expression, if I now go here, so we can there are different types of expression that we can build over. So we'll go into it later. So here, just let me go through one of them. Let's say suppose we have a string expression 2, which is genre equals to sci-fi, and year is less than 2000. So these are basic query, like it's quite simple. It's a SQL like query. So this, if we pass it, so what it will do is it will filter out based on first all the metadata like this year and genre, and after that whatever the result remains, on top of that it will do our query based search, right? So here I'm just passing genre. It can be anything, right? We will ideally pass some plot information, right? So after that, when we pass, when we are doing query, so you can definitely understand that we are already pre-filtering everything, right? So the amount of computation will be less compared to if we haven't used filter expression, right? So now if I go back to my, let's go here. Yeah, so how we can do it is you can use a filter expression builder. So here one way is we have this inbuilt functionality in our Spring AI module, which is the new filter expression builder. We can create an instance of it, and then what you can do is we can use this p is my builder. So p dot equal then whatever meta information we have, like title, and then we can work. So it will make a build of it. Or we can also use these operations that we have already seen, and in all those of operation we can use to have a complex logical. We can also have a string-based filter. So here you can see it's a filter expression builder, which is a class instance here. And here it is a string expression. So this is one of the another way. So if I go here, we can do a group like we have already seen. There is a group expression. So we'll go into more in the code directly. So it will be easier to explain. So if I go one by one, so if you see here, the first expression 1, it is what we are doing is we are doing it using a parser. So here it is filter expression text parser. So this is one of the methods. So using parser, and then we are passing on the string here, right? So this will create a expression 1 of type filtered or expression, right? Other is string that we have already looked into. Other is the builder that we store in our PPT. So this is the filter expression builder. So here what we are doing is builder and then we are doing a builder dot equal genre. So this ideally means the same thing, right? Genre is this, and we are making an AND operation. So AND is this, and another one is the year is 2000. So this, if I have to convert it into an expression, it will look like something like this, right? So another one is like it is equals to less than equals to, it is less than equals to, and in operation, basically we are using a set operation, right? So here in, and we can pass on different values here. So if you see here, values we are passing. Genre can be sci-fi, action. So we are passing all of them inside in the operation. So this is another one, right? We can use. So then if we have to build a complex operation of using groups, right? So we talked about group. So let's assume, so we are trying to build an expression which looks something like this. Title is this Shawshank Redemption, or, and then we have another expression which is year is less than 2010 and genre in between this, in between, not in this set, right? So this is a complex operation where we have an OR operation, and then inside this we have another expression, right? So this is what we did here. We created one operation here. So it is under filter expression builder dot op, right? So builder dot call, and we're giving this one social redemption here. Then we're creating another operation, right? Which is builder. This is basically same as this, right? What we are trying did here expression for. So this is the same thing, but here we're giving it as op, right? The instance, the type is op. So now then what we are doing is we are combining both of them. So expression 5 looks like builder dot group. So here that's where we're using group, right? Group. And then we are doing a builder dot or. So basically this operation op 1 or operation opt, right? So this or, so this is the one op 1 and opt 2, and then we are doing a bit. So this is kind of a complex query that we are building out. So these are the different ways. So another thing that I should highlight here is you can see here's a, so one is like the string expression, right? So we can directly, why do we again actually need to go with filter expression builder if we can directly pass string? You can see here, we are making it complex, right? It seems like we're making it complex by creating expression builder. So it's because like, you can understand like if we have a string operation, so it is complex to, we can have it wrong, right? The entire expression can be actually wrong. Or, and what happens is if we are parsing it, whenever we are parsing it, putting it into filter expression, inside if you are passing it as a string, it will indirectly parse it, right? So if the string query has some fault here, anywhere, so the entire parsing would fail, right? So inside what it does is it's converting this filter expression to, if say, suppose my expression 2 is a string, right? So inside it will convert it into expression, filter to expression, right? And then it will do the similar operation. Basically, directly we are converting from string to expression. If it is an by default, it is just, but we don't want to do that. We want to avoid this string unless we are totally sure about it. So yeah, so this is here. This is it for this topic on filter expression. You see, yep, this is it. So we will go into our, we'll see what we can cover next on this Spring AI topic. Right? Thank you for watching.